Hello everyone, so my name is Nitin Bharti and today in this video I am going to demonstrate the Redwood viscometer experiment of energy source and utilization value. So this is our Redwood viscometer. The aim of this experiment to calculate the viscosity of given sample using Redwood viscometer. So I am going to tell you about the technical terms related to this Redwood viscometer. This is water bath. Here there is water by which we just increase the temperature and we reach the desired temperature of the bath. This is stirrer by which uniform temperature is everywhere in the water bath. This is ball valve by which we close the eyes and start the experiment. This is called
oil cup.
With the help of this thermometer we measure the temperature of given sample. Now this is called measuring flask. Here we have to collect the 50 centimeter cube, that is 50 ml of given sample up to this mark. This is our controller. We have to set the temperature. This is the switch for light. This is switch for stirrer and this is the main switch. This is indicator.
This is the sample container which we have to take the sample up to the mark 50 ml, and here we can see the machine where this is the mains, this is the switch for the light, this is for the stirrer, this is the temperature display where we can set the required temperature, this is the increasing button, the decreasing one and the exit button, and this is the heat regulator. So here, coming up with the theory part, we can see the two words. One is Redwood second, the second is Redwood viscometer. So what is Redwood second? The time taken by the lubricating oil to flow for a particular time is the Redwood second. And what is Redwood viscometer? The setup we can see here, which calculates or measures the viscosity, kinematic viscosity, dynamic viscosity or absolute viscosity of a given lubricating oil, is the Redwood meter. In comparison with the Engler's viscometer, we can see here the ball valve. Let me show. Here we can see the ball valve in Redwood viscometer, whereas we can see straight pen-shaped valve in Engler's viscometer. Whereas the sample container used in Redwood is of 50 centimeter cube, whereas the sample container used in Engler's viscometer is of minimum 200 centimeter cube.
We will start the experiment by making sure that the ball valve is completely filling up the orifice opening and that the measuring flask is directly below the orifice opening. First, we will pour the lubricating oil up until the pointer position, until the pointer is completely submerged till that point, and then the first reading will be done at the room temperature. So, simultaneously we will be starting a stopwatch and then opening up the ball valve. Here we will calculate or record the time it takes for the measuring flask to fill up to the 50 cm. After 15 minutes, we observe that the measuring flask has collected the required 50 centimeter cube volume of sample. Now we have transferred all the liquid sample into the oil cup, and then we will again close up the lid, and we will make sure that the ball valve is covering up the orifice opening. For the next few observations, we will make sure that the reading is taken at a temperature higher than the room temperature, so as to make sure that at high temperature the viscosity of a fluid sample decreases. Now we would give the power start. Now we will set the required temperature by here. We will press the set button for a few seconds till this icon appears, and then reduce the temperature to our required temperature. At first, we would take the required temperature around 50 degrees Celsius. We have set the desired temperature at 53 degrees Celsius because the water bath surrounding the oil cup would be around 53 degrees Celsius. And because of the heating and the equilibrium, the temperature in the oil cup would be a bit lower than that. While the stirring is occurring, we would make sure that the thermometer is not placed inside, and after the desired temperature has been reached, and then now that we have attained the required temperature, which we can check by the thermometer, and then we will take off the ball valve and simultaneously start a timer and record the time in Redwood seconds. Now you can see that the sample is dropping into the measuring flask, and after the 50 centimeter cubic volume has been attained, we would again close the orifice opening, and then we would complete our experiment.
We have discussed in this experiment how the viscosity is being varying with the temperature, the theory and the introduction part. For now, moving ahead with the calculation and the observation table, we have discussing. For the calculation, we have to know the exact figure or the exact value of the viscosity at a particular temperature. For that, we have the observation table here, where we have got the first the oil temperature, and second one is the time taken for taking 50 centimeter cube of the sample in a measuring flask, where we have calculated the kinematic viscosity and the absolute viscosity. For the kinematic viscosity, we have one formula, A into T minus B by T, where A and B are the calibration constant, whereas for the absolute viscosity, we have calculated by the means of kinematic viscosity, whose formula is kinematic viscosity into density. Now I am going to telling about the significance of Redwood viscometer experiment. Redwood viscometer experiment is significant for various industries and applications, and it plays a crucial role in quality control by determination of Redwood viscosity of different types of oils and lubricants, and it can be converted into kinematic viscosity also, and it also uses the temperature effect on viscosity. There are some flowing applications of this experiment. The Redwood viscometer is used in petroleum industry for determination of viscosity of crude oil and petroleum products, and it also uses in automotive industry. Viscosity of engine oil, it directly affects the engine performance and longevity. So the Redwood viscometer is used to determine the grade of viscosity of oil for different types of engines.
Now I am going to tell you about the conclusion of this experiment. First of the conclusion that I concluded that as we increase the temperature, our viscosity decreases. Means we can say viscosity in Redwood viscometer is inversely proportional to the temperature. Second, we had concluded that Redwood viscometer is more efficient than Anglers viscometer, as in Redwood viscometer flow of the oil is in a drop wise, while in a Anglers it is flow wise flow, which concluded that in Redwood it is more efficient than Anglers